Welcome to Multiple Choice Question 8 of the 2009 Mathematical Methods Exam 2. In this video we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. And now before we move on, I'd just like to point out that the use of a CAS calculator is an efficient way to approach this question. For question 8 we have for the function f, which has a domain of all real numbers, for a rule f of x equals x plus 5 squared times x subtract 1. For this function, the subset of R for which the gradient of f is negative is given by one of the following. So if we want the gradient of f to be negative, that's the same as asking when is f dashed of x, when is the derivative less than 0, but not equal to it. We just want when f dashed is negative, and 0 is neither negative or positive, so we can't include it here. On the CAS calculator, go into the main menu. Next, what we want to do is type in an expression for the function f. So we had x plus 5 to the power of 2 multiplied by x subtract 1. And the first thing we want to do is calculate the derivative. So we go interactive calculation diff and we click OK, and that is an expression for the derivative f dashed of x. And from the CAS calculator we found that the derivative had an equation 3x squared plus 18x plus 15. So we want when that is less than 0. Next on the calculator, highlight the expression for the derivative and drag it down. And then using the keyboard, we want to go to Math 3 where we can find our inequality symbols. So we want when the derivative is less than 0. And then we can highlight that and go interactive equation inequality solve for x, and hitting OK will give us our answer. And the CAS calculator gave in set notation that negative 5 is less than x, which is less than negative 1 as our answer. So we want it in interval notation, that's what the answers are given in. So option C is the correct answer, as that interval describes x is an element of negative 5 to negative 1, both not included as they're in round brackets. So option C is the correct answer for this question. From the examiner's report, we can see that almost 80% of students got this question correct, so it was fairly well done on this exam. And if you wanted to, you could have considered a graphical approach. So this is the graph of the function f, and we can see that all the values from x is negative 5 through to x is negative 1 would have negative values for their derivative, and that is that we'd have negative tangents drawn, or gradients that are negative for all tangents drawn in that section there. Likewise, we could look at the derivative graph, and when we want a negative gradient, we want dy dx to be less than 0, so we want it to be under the x-axis, and that occurs when x is between negative 5 and negative 1, which is what we solved on the calculator on the previous slide.